Hello again, everybody. Mr. Wakefield here, looking at section 5.5, and once again we were going to be looking at inequalities just like we did in the last video, but this time the key thing is that it's going to be two variables instead of just one, and just like when we were graphing equations, all right, when you have two variables, that's normally, not always, but that's what normally you would do. When you have an equation with two variables in it, you graph it, whereas when you have an equation with one variable, you solve it. Okay, again, usually that's true. So solving with one variable and graphing with two, when we had equations with with equal signs and stuff. And so as it turns out, when you have inequalities with one variable, once again, one variable, just like we saw in the last section here, 3.8, when you have one variable, you solve usually, and then no exception here. But in this section, because you have two in most of these, here the y is invisible, but basically we have two variables here in this section. It would make sense that we would graph it on an xy graph, not a number line this time, but an xy graph with the x-axis and y-axis, because we have two variables. All right, so you got to have the x-axis and the y-axis. So you can see this kind of some similarities there between equations and inequalities as far as the difference between one variable and two variable. Okay, so now why do we have to graph this? Well, it's kind of similar to when we graphed equations. Right? That's how you illustrate the solutions. Okay, in fact, it says that here: graph the solution set. All right. We did graph the solution set in the last section, all right, as a part of solving the one variable linear inequality, okay, but we put it on a number line because there was only one variable. Therefore, you didn't need an x-axis and a y-axis. You just needed the one axis right there, and it was the going across here like an x-axis would. But here, we're going to illustrate the solutions on, again, an x-axis and a y-axis because we have two variables here. So we need to illustrate that solution. All right. And you'll see here that there's a lot of similarities to the last section as far as how the graph works, in fact. It's just that here we don't have a number line, that's all. So let's get started here, and then we'll go over some of the similarities here just so you can make some connections here, because it always makes it easier to remember things when you make connections to other things that you've already learned. So let's get started here, and then we'll talk about those things. First thing here, when it says to graph a linear inequality in two variables, okay, is to graph the corresponding equation. What that means is temporarily change the, and I want to make it clear, temporarily, okay, just in this step, change the inequality sign to an equal sign. So you're going to take this alligator mouth, the inequality sign, in other words, we're going to temporarily change that to an equal sign here. And we get 4x plus 3y equal to 15. So in other words, the entire problem stays the same except for the inequality becomes an equal sign. All right, now, as we learned at the very beginning of chapter 4, when we first learned about how to graph lines, we know that when you have a two-variable equation with an equal sign, two variables, and it's linear, meaning that both sides are polynomials, you don't have any x squareds or any y squareds, you just have x to the first and y to the first, that kind of thing. That's when you have a line. That's when the graph is going to look like a line. All right. So that's exactly what this will be. This will be a line, just like we saw at the beginning of chapter 4. Now, when we had these lines here like this, or these equations like this, we learned that not that it's the only way to do it, and I'll get into that, I'll review that with you again here in a little bit, but one of the things that we did was we learned that you can plug in a couple of numbers, okay, and solve for the other variable. Like, for example, here I plugged in x equal to 2, and then I solved for y. And I found out how those paired up. And then I plugged in y equal to 0. And I solved for x. All right, so you could plug, when you have both variables visible there, you can plug any number you want, and you can plug it into either variable until you get two answers here, two ordered pairs, and then you graph it. All right, so just a little review right there. We also learned a different method, which I'll review with you here in the next problem. But if we do that same thing here, plug in a couple numbers. All right, plug it. You can plug it in either variable here. I'll go ahead and plug in x equal to 0 here. Remember, 0, not always, but oftentimes is a good choice when you have all these choices here. So if I do that, again, you figure out what the term is equal to that you plugged into in this type of situation, in this type of problem, like we did in Chapter 4. 4 times 0 is 0, and we know that when you plug 0 into a term of a polynomial here, this is a two-term polynomial here, that term is just going to disappear. Completely disappear, because 4 times 0 is 0, and 0 plus 3y is 3y. So it's as if that term just completely went away, the 4x term. That then leaves us a normal linear equation here, one variable linear equation. We solve it by dividing out the 3 there, and we get y equal to 5, don't we? Okay. And so that means that 0 pairs up with 5 right there. I'll graph that in just a moment. But I still need to find one other point, don't I? Okay, I'll go ahead and plug in y equal to 0. Why not? Okay, and so if I do that, isn't the 3y term going to disappear this time? Because you're plugging 0 into the 3y term. Okay, meant to make that, that's still an equal sign in this step right here. But that should disappear completely, because you plug 0 into a term of a polynomial. That term should then just disappear. That leaves me with just 4x equal to 15, because 3 times 0 is 0, and 4x plus 0 is 4x. That's why it disappears again. I then divide out the 4 like I would in a linear equation there, and I get x equal to 15/4. Now I want to know where that is on the graph, so as I taught you guys back in Chapter 4, if you have a fraction as an answer and you need to graph it on your XY graph here, and you're trying to figure out where it is, okay, you can put that in your calculator and you get a decimal answer, and then that tells you where it is. Same thing here. When I get this fraction answer, 15/4, if I put that in my calculator, that is going to be 15 divided by 4 equal to 3.75. Okay, 3.75. So we know then that that is between 3 and 4. 3 point something is between 3 and 4, right? So let's go ahead and graph those two things, those 2 points. Just like we always do when you figure out what your 2 points are, you graph them and then you draw your line, just like in Chapter 4. Okay, 0, 5 is right there. Okay, that first point is right there. 3.75 and 0, that one would be y is equal to 0, so it's right on the x-axis. But 3.75 means that it's between 3 and 4, and you don't have to be any more exact than that. Okay, just put it between 3 and 4, and that's fine. Then we need to draw the line, but don't draw it yet. There's one thing about these problems that's a little bit different than when we drew lines before, and this is when we get into Step 2. Step 2 says, before you actually draw the line, it says what? It says if the inequality sign has alligator feet, then you make it a solid line. Okay, kind of like, in other words, a solid line is similar to a square bracket from the last section. If it's got alligator feet, you use a square bracket. But if it's a problem that has two variables and you're putting this thing on the bigger x-axis, y-axis type graph like this, then you have a line that is a solid line. Okay, a solid line. And so if the alligator mouth did not have feet underneath it, then you'd use a dashed line. Okay, a dashed line, not a solid line like this. We'll see that here. In fact, we'll see that in this problem, because you can see that there's no alligator feet here, right? It's just strictly greater than, not greater than or equal to. And so what I'm going to do is I'm going to draw my line here. But when I draw it, I am going to make it dashed. Just a bunch of dash marks here. Okay, it's still a normal straight thing like a line would be. See that right there? Okay, see how I've got my normal straight line, but it's in dashes. Okay, you need to do that to indicate that it's not. It's one of those things where the alligator doesn't have feet, and I'll tell you why that's important here coming up. Okay, after we finish the problem here. But when the alligator doesn't have feet, you want that to be a dashed line when you have a two-variable linear inequality. Okay, so this is going to be dashed, all right? But make it solid. In the next problem, we're going to make it a solid line, right? Because the alligator's got feet. In the next problem, same thing. We're going to make that solid as well. All right. This one, what's this one going to be? This one's going to be solid too. Again, if the alligator's got feet, you're going to make a good solid line like you normally would. But in this problem over here, the very last problem, number 2, that's going to be a dashed line because the alligator does not have feet. So it all comes down to what kind of inequality you have. All right. Now the last step, there's 3 steps. The last step is we need, what happens here with these 2 variable linear inequalities is and this is going to sound like the last video almost, you're going to have a shading. And the shading is either going to be completely on one side of the line or it's going to be completely on the other side. It'll either be above it or below it. Okay, does that sound familiar from the last video where we learned that you had a shading either on one side of the number or on the other? Well, this time, instead of having a number as the boundary for the shading here, where the shading is on one side of it or the other, and therefore that number is a boundary for that, this time the line is the boundary, and the shading will be completely either on one side of it or completely on the other side, just like it was here. Okay, so think of the line. The line is like the number was. The line is like the number was, where it's like a boundary, and the shading is always on one side of it. Okay, and so the how do we figure out what side is shaded? All right, well, you can't do it. I want to make this clear. You can't do it the same way we did in the last video. Okay, you can't just look at the inequality and say, oh, hey, the variable is greater than. No, that's not how it works because there's 2 variables here. It's a little bit more tricky when you have more than just one variable. You cannot do that same thing where you just say, oh, hey, the variable is greater than, therefore I go to the right or something like that. No, that's not how it works. That's not how it works. Again, when you have 2 variables, it's more complicated. That whole simple thing that I talked about in the last video does not work here. So what you have to do is use a test point. Okay, you could pick any point that you want. See how it says right here, choose any point. And they mean literally any point, as long as it's what? Not on the line. Okay, so you could pick any point above the line. You could pick any point below the line. You just have to pick one. All right, just make sure not to pick one of the points that's right on the line. And that's going to be our test point. So I'm going to pick 0, 0. Again, 0, 0, like I've said before, zeros are oftentimes good choices for things to plug in if you've got a choice of any number you want. And so since 0, 0 is not on the line, why not pick that? But very important, you have to plug it into not into the equation with the equal sign. You have to plug it into the inequality. All right, remember I said that when we changed it to an equal sign, that was only temporary. Okay, in the last step, you got to plug whatever point that you're using. In this case, I'm using 0, 0. You got to plug that point into the inequality. So that inequality symbol comes back into play here. All right, just take the original problem with the inequality in it and put that point in there. X equal to 0, Y equal to 0, plug that in, and then what you do is you figure out if this is true or false. Okay? It's kind of like when we were checking our answers in the radical equations, okay? You got to figure out if it's true or false. So what you do is, just like with the radical equations, you figure out what each side's equal to, and then see if this is true or not. All right, so 15 is obviously 15. That's not going to change. There's nothing to compute there. But what is 4 times 0 plus 3 times 0? Well, multiplication comes before addition, right? So that would be 0 plus 0 on the multiplication. 0 plus 0 obviously is 0. And so is this true or false, you guys? Is 0 greater than 15? Remember, the numbers don't need to be the same now. This is not an equal sign. Okay, it's an inequality, so you got to look at it more carefully here. Is 0 greater than 15? Actually read it there and ask yourself, is that true or not? Well, 0 is not greater than 15. We know that 0 is less than 15. So that is false, isn't it? Okay, that is false. All right, now what does that mean? Okay, here's what it means. Remember I said that the all the solutions, in other words, the entire shading, is all on one side or the other. Well, a solution, by definition, is something that makes it true. Okay, so if 0, 0 is false, then that must mean that all the true answers have got to be on the other side from where the 0, 0 is, which is on the top side here, because 0, 0 is on the bottom, it's underneath the line. And so since that's false, then that must mean that the true answers have got to be on the other side. One side is going to be true and one side is going to be false. So if this is the false side, the other side's got to be the true side. So in other words, if you plug in a test point, you guys, and you get false, shade the other side from where that point was located that you tested. Okay? Because that must be the false side. All right? One side's going to be true, one side's going to be false. So if that point that's below the line is false, then that must be the false side, which means that the other side, in this case the top side, is going to be the true side. Now notice what I'm doing here. I'm shading this very thoroughly here. You don't need to be an artist. I'm not expecting you to be. If you are good at art, that's even better, but it's not required. Okay, but notice I gave a good solid shading here, right? That went all the way to the ends of the grid here. All right, you know, like this imaginary box here that makes up the outer edges of the grid here. Just make sure your shading goes all the way to the ends of that. Do not be lazy about this, okay? I just want to make sure everybody gets full credit on this. Don't be lazy about this and just go whoop like that, okay? Don't just have a line like that, like this. Don't go like this, all right, where you got the line like this and then just go like that on that side of the line. Don't do that, all right? You got to give a good solid shading on one side of the line, whatever side the shading goes on. If you just give a little squirrely mark like this right here on one side of the line, that's not going to tell me, you guys, that you're declaring, as you should, that every single point on that side of the line is a solution. Every single one. If you just give a little squirrely line on one side of the line, if you get a little squirrely mark here on one side of the line that we had in step 1, okay, that is not going to be convincing enough. A good solid shading here will be convincing, all right? It goes all the way to the end of the grid there, all right? It doesn't got to go beyond the grid. You don't have to go all the way up here, okay, beyond the problem here on the rest of the paper. It just has to go all the way to the end of the grid that is comprised of that imaginary box that goes around the edges of the grid. Okay, that's as far as it has to go. And you can see I did that here. I went to the ends of the grid here. That's what I'm talking about. All right. So good solid shading is what we're looking for. And that's it. That's the whole problem. All right. So let's review here. We have what? We have to graph the line, determine if it's solid or dashed. Okay. And then use a test point to see where the shading is, and then draw your shading, you're done. Okay? Let's try that again. What's the first step again? The first step again is to temporarily change this into a equal sign, like this. Okay. Now notice that kind of looks like y equal to mx plus b, right? Remember that from section 4.4? I'll review it with you here if you don't. Okay. Remember when we were getting problems into the y equal to mx plus b form, we have y equal to a constant number times x plus another constant number. All right. This is the same thing here. If you remember that when the B part is missing, there's a plus 0 right there. You don't have to write the plus 0. I'm just writing it there so that you can see what I'm thinking here. Okay. So that's the y equal to mx plus b form. All right. You could have done the y equal to mx plus b form over here as well. by getting y by itself. We saw that in a few of the problems back in 4.4 right here. This kind of looks similar to the first problem that we did in this current section, where you could have, if you wanted to, gotten the y by itself and then done the slope and the y-intercept thing, graphed the y-intercept first, and then did the, in this case, the drop and run. Okay, or the rise and run if the slope is positive. All that stuff that we learned about graphing with slope and intercept, all right, from section 4.4, you could do that if you want. That's okay. All right, you could have done that in the first problem. I just elected, because you can always, whenever you have both variables visible there, you can always do this thing where you just plug in a couple of numbers. But you also have the slope intercept strategy that you can use as well. It's your choice. All right, as long as you have both variables, you could do, as long as both variables are visible, that is, you could do either method. All right, I could plug in a couple of numbers into this equation too, just like I did over here, and that would be fine. All right, as long as you know what you're doing, you could do either method. Now, when we have just one variable that's visible, I'll review that with you again. That's different. But when we have both variables visible here, okay, you could do either method. Either plugging in a couple of numbers or doing the y equal to mx plus b thing. All right, and then what do we do after we get it in the right form, y equal to mx plus b? We then figure out what the m and the b are. All right, the m is negative 2/3 here because it's being multiplied by the x. All right, so the slope is negative 2/3. Remember, when the slope is negative, you drop and run. The y-intercept is 0, isn't it? Because the b number is 0. So remember what we did back in section 4.4, again, is that when you know what the slope and the y-intercept are, is you graph the y-intercept first, and then if the slope is negative, you drop and run to get to the second point before you draw your line. If the slope is positive, like in this problem here, you then rise and run. Rise 1 and run 4 in this case. Okay, again, this is all from section 4.4 if you want to look at that again. So let me go ahead and do that here. There is the y-intercept right at 0 there. And then because the slope is negative 2/3, I am going to run, or pardon me, I'm going to drop 2 and then run 3 to the right. Again, don't draw your line yet though. We're ready to draw it, but there's one thing we have to consider in these inequality problems, and that is, what kind of inequality do we have? Well, since the alligator's got feet, we are not going to do a dashed line this time. We are going to do a solid line, like we mentioned in the first problem. So let me go ahead and draw that solid line right there, since the alligator's got feet. Okay. Make sure your line goes all the way to the ends of the grid. Okay. We didn't always do that in the past. But it's important here because remember, the line now serves as a boundary for the shading. And since the shading, as I mentioned in the last problem, has to go all the way to the ends of the grid in order to indicate that it's that entire side of the line is where the shading is supposed to be, all right, it would also make sense then that your line would go from one end of the grid to the other. So in other words, don't make a little tiny line like this, okay? Don't make it really small like that. Make it go from one end of the grid to the other. All right? Okay, now, I've done my line. I've figured out that it was solid, okay? So I'm going to jump right to step 3 here. That's the step where I use a test point. What test point am I going to use? Again, notice though, this time though, that 0, 0 is right on the line, isn't it? So you can't use that this time. Okay, I like to pick 0, 0 whenever it's not on the line because you have to pick something that's not on the line. Okay, as it mentions up here, not on the line. That's what you choose. So let's pick something else that's not on the line here. How about say 1, 1 right here? 1, 1, that's right there. That's clearly not on the line, right? Make sure that it's definitely not on the line. If you're not sure, don't pick it. Okay, pick something you definitely know is not on the line. So I picked 1, 1. Plug it into the original inequality here. And we get what? We get 1 is greater than or equal to negative 2/3 times 1. Okay. Figure out what each side of the inequality symbol is equal to. 1 obviously is just 1 there. What is negative 2/3 times 1? Well, anything times 1 is itself. Okay. And since this is a positive number and this is a negative number, that's definitely true because a positive number is always bigger than a negative number, right? Okay. When it says greater than or equal to, by the way, it just needs to be one of those two things, either greater than or equal, in order for it to be true. Okay. It just needs to be one or the other. That's why I say greater than or equal to. Okay. Either one is fine. So since it's greater than, it's going to be true. All right. Now, what does that mean? Well, where did that point that I chose for the test, where did it come from? It came from above the line, right? So since that's true, okay, that means that that's the true side. And you always shade the true side because that's where the solution sets are. The solution is where it's true. And so we need to shade the solution, and therefore we need to shade where it's true. So since the top of the line is where the true point was, therefore that's the true side. So let's again review here once again. All right, if it's false when you plug in the number, you shade the opposite side of where the test point was. All right, and I did that. Okay, the test point was below, I shaded above. All right, but here it was true, and so you shade the same side. All right, 1, 1 is above the line. You stay right there. You don't go to the opposite side this time. You stay right there. So I'm going to shade that same side that the test point was on. Again, a good solid shading that goes all the way to the ends of the grid there. All right. Don't let it cross over to the other side of the line. All the solutions are only on one side of the line here. Okay. And there we go. So you can see I'm making a good solid shading, all right, that clearly indicates to the person reading it that the entire top side of the line is a solution. All right. Sometimes you will shade below the line in some problems, okay? I know we haven't seen that in these first two problems, but it will sometimes happen. All right, now, in the next one, again, what's the first thing that we do? I know you don't see two variables here, but whenever you see an x-axis and a y-axis, you guys, even if you only see one variable in the actual problem, the fact that you have both an x-axis and a y-axis tells you that there's actually two variables here. So it just means that the y is invisible then. Okay, they wouldn't have a y-axis here if there wasn't an actual y in this problem. So if you don't see it, it's just invisible, that's all. Okay. And we've seen that kind of thing before. All right, back in sections 4.1 and 4.2, at the beginning part of the last packet, we learned that when you change this to an equal sign right here, which is what we always do on the first step here, we can see that this is similar to a problem like this, where you've got no y here. It's an equal sign, so we're going to be graphing a line here. It's an equal sign, but the y is missing. Whenever the y is missing, it's always going to be a vertical line. Whenever, any time. Okay, so over here the y was missing. Sure enough, we had a vertical line there as well. All right, so you just got to know what the x is equal to. Over here, I needed to get the x by itself to figure that out, and then I graphed the vertical line. Here, the x already was by itself. It was equal to 2, so I put the vertical line at 2. Same thing here, all right? The x is already by itself. It's equal to 4. That means you go over to x equal to 4 on the x-axis, and you draw a vertical line there. Is it going to be solid or dashed, though? This inequality right here with the alligator feet tells me that that is going to be a solid line because it's got feet. All right, so let's draw a solid line that's vertical at x equal to 4. All right. Okay, so there we go. And so step 1 was to draw to figure out where the line is. Step 2 is to figure out if it's solid or dashed. You then draw the line after you know that it's solid or dashed. Okay, so the solid part is step 2, figuring that out. if it's solid or dashed. And then step 3 is we pick a test point. Is 0, 0 on the line this time? No, it is not, right? It's 0, 0 is way over here. So I'll pick that this time. Now, how do I plug this in when one of the variables is missing? Well, if one of the variables is missing, you guys, you just have to plug in the number that goes with the variable that is visible. In other words, since the y is missing, you don't need to plug in the y part of your ordered pair that you picked for the test point here. Okay. If the x had been missing, then you don't need to plug in the x part of the ordered pair that you picked. All right, so you can ignore that since there's no variable to plug that into. So I just need to plug in the x equal to 0 right there, since x is all we have here, and we get what? We get 0 greater than or equal to 4. Is that true or false? Is 0 greater than or equal to 4? No, it's less than 4, right? 0 is definitely less than 4. So this is false. Where is the point that I tested? It is over on this side of the line, isn't it? Okay, there's this side of the line over here, and then there's this side over here on the left of it. Okay, the point I tested was on the left. It was false. What does that mean? Well, it means that we always shade the other side if it's false. Okay, so since that point that I tested was on the left, I am going to shade on the right side. Like that. Every single point on the other side is true because the point that I tested was false. Whenever you have a false point, then the point, the side that point is on, all those points are going to be false. But then the other side, all those points are true, and that's why you put the shading there. Okay, so please try 1 and 2 right here, very similar to that. Okay, you can see that this one looks kind of like the y equal to mx plus b form, although you could do it, you can graph the line however you want, like I said. And then in number 2 here, you can see that number 2 looks very similar to problem A right here. So you could, after you change this into an equal sign, you could just plug in a couple of numbers. But again, like I said, you can also make this into y equal to mx plus b. Okay, just remember to change this to an equal sign first, no matter what. Okay. Before you do that. That does matter, all right? Mainly because if you did get it into the mx plus b form, you'd have to divide by a negative to get the y by itself, and then that would flip the inequality symbol, all right? Now, maybe you'll remember to flip it, okay, and that's good, okay, but if you don't, all right, then that would create a problem. So the best thing to do, like we've done on all these problems, is to change it to temporarily to an equal sign when you're in that first step and you're graphing the line, okay? And if you do that, then you don't even have to worry about remembering to flip that inequality when you divide by negative, okay? Just use that equal sign in step 1 and you'll be fine. Okay, so try 1 and 2. We'll see how that turns out after you hit the play button, and we'll wrap things up here. Okay, so let's take a look at number 1 here. Temporarily changing it to an equal sign, we get y equal to 3x minus 4. That is already in the y equal to mx plus b form right here. Okay, where you can see that the 3 would be the m. In other words, the 3 would be the slope, and so I said 3 over 1 for the slope. The b would be negative 4, and so therefore the y-intercept is negative 4 right there. So what I did was I put the y-intercept, like always, I put the y-intercept on the graph first. Then I do the slope. And since it's positive, I'm going to rise 3 and run 1. Let me do that. 1, 2, 3 rising, and 1 running across to the right. And I end up right there. And so that means that I need to draw the line now. But is the line going to be solid or dashed? It all comes down to this right here. The alligator's got feet underneath it. That means we're going to do a solid line when that happens. All right, remember, solid lines are just like square brackets in the previous section. All right, if the alligator's got feet, you use a square bracket in the last section. But when you got these two variable inequalities where you're drawing the lines, all right, that's when you use a solid line as your boundary instead of a square bracket as your boundary. All right, when we did the problem up here on the top, all right, The round brackets in the last section were similar to the dashed lines. Okay, when you don't have the alligator feet, all right, in the last section we used a round bracket as a boundary. Now the dashed line will serve as a boundary when you have a two-variable inequality that you're graphing. Okay, so round brackets are like dashed lines, solid lines are like square brackets. Okay. All right, back to this problem. We still have to do step 3. You can see that I plugged in 0, 0 because it's not on the line here. It's to the left of it. Okay, when I plugged that in and I did my order of operations on each side of the inequality here, multiplication comes first and then subtraction. We get -4. And this is true because 0 is greater than any negative number, including -4. So I said true. What does this mean, though, as far as the shading? It means that since the point that I'm testing is on the left of the line, and since it ended up being true, then the shading will be, that must be the true side, okay? Therefore, remember, when you get a true answer on the test point, you shade the same side that your test point is on, because that's the true side, all right? You don't go to the other side like you would if it had been false. So let's go ahead and draw a good solid shading here. Okay. All the way to the ends of the grid there on that side of the line. There we go. All right. Again, you don't need to be artistic, just so long as it's as a good thorough shading that comprises the entire side of the line where the shading is supposed to go. And that's it for that problem. Number 2, okay, we temporarily change it to an equal sign. Again, you could do the y equal to mx plus b thing here if you want. I went ahead and did the other method here where you plug in a couple numbers. I decided to plug in x equal to 0 and y equal to 0. When I plugged in x equal to 0, I got y equal to -6. After that term disappeared, all right, we divided out, we got -6. When I plugged in y equal to 0 over here on the far right of the problem here, that term disappeared right there, and we ended up with 5x equal to 12. Divide out to get the x by itself, and you end up with 12/5. But I want to know where 12/5 is on the graph, so I put that in my calculator. 12 divided by 5 is 2.4, and so I get 2.4 matches up with y equal to 0. I then put those 2 points on my graph here. 0, -6 is down here. 2.4 comma 0 is right here. Remember, 2.4 is between 2 and 3. And so I just put it between 2 and 3 right there. Is it going to be a solid or dashed line here? The alligator does not have feet up here, and so that means it's going to be a dashed line. Let's go ahead and draw a dashed line. Okay. Just give me a second to do that. Like that. And so there's your dashed line right there. And the last step here is to, again, realize that 0, 0 is not on the line, so you could pick that. You don't have to pick 0, 0. You could pick anything you want as long as it's not on the line, but I just like to pick that when it's not on the line because it's easy to plug in usually. So I plugged it in right here, okay. Multiplication first right here, we get 0 plus 0. Okay, remember when you plug in, and it's not going to make any difference in this case, but sometimes it does. But remember when you have a polynomial that you're plugging into, and the second term of the polynomial here, 5x minus 2y, if that second term is negative, remember that is plus -2 times whatever you plug in. So that's why it's plus -2 times 0, which is plus 0. That's why you see the plus there instead of the minus. Anyway, 0 plus 0 is 0. 0 is less than 12. That is true. Okay, 0 is less than any positive number, including 12. Okay, what does all this mean, though? It means at that point, that you tested, which is on the left of the line, okay, is true. And so therefore the shading goes, that must be the true side then, since it's true, and therefore you shade on that same side because you always shade the true side. Again, if it had been false, then you'd shade the other side, because if it had been false, that would be the false side. And you always shade the other side if that's the false side, because you want the true side to be shaded. All right? One side is false, one side is true. So if this had been false, you shade the other side then. Okay, but since it's true, then we shade the same side that the test point was on, okay, which is on the left of the line here, obviously. And so let's go ahead and shade that. Okay. Just give me a second to do that here. All right. So I think you can see a similarity here between this section and the previous video in section 3.8, where with inequalities, you guys, when you do the graph, whether it's on a number line when you have just one variable, okay, or if you've got problems like this with two variables, all right, you always have a shading and you always have a boundary. It's just that in the last section, the shading was just a line of shading and the boundary was just a bracket, whether it be round or square. Here, when you have two variables, you still have a shading. It's bigger, but you still have a shading, and you still have a boundary, but this time the boundary is a line. And just like the boundaries in the last section, sometimes they were round brackets, sometimes they were square brackets. In the same way, we have two different types of boundaries in this section. It's either going to be a dashed line or it's going to be a solid line. So you can see a lot of similarities here between this section and the last one. All right, so let me know if you have any questions about inequalities. Okay, so have a good day, take care, and we'll see you back for the next video, which will be section 5.2.